Hey guys, so today we're going to start taking a look at functions. So first let's talk about what a function is. A function is a relation or relationship or rule that assigns each input or x value exactly one output or y value. So what I want you to do is take a moment, pause the video, and copy these notes exactly as you see them, okay? So now that you've copied the notes, let's actually look at these. How to decide if a relationship, a math relationship, is a function or it's not a function. So first, let's look at maps. And the main thing that I want to point out is that x cannot repeat. That's the main idea that we want to take a look at here. So whenever I look at maps, I want to look at my x, or let me make this a little bit bigger. I want to look at my x or my input oval. And here I notice that each one of these just has one line coming out from it. That's what makes that a function. Look at this second one. Each of these have one line coming out of them. Now the y repeats. I don't care about the y. The y can repeat as much as it wants to. It's just the x that cannot repeat, which brings me to this non-example over here. So take a look at this x value right here. It has two lines coming from it. That's why it is not a function. So now let's look at points. So the first thing I want to remind you of is that points are written x, y. So the first number is our x. So guess which number we're going to look at to decide if it's a function. We're going to look at the x values. So here we have 1, 3, 5. Yes, it's a function. Look at the second set down here. We have 1, 3, 5. Now, we have the same the same y, 2, 2, 2. I don't care about the y. All I care about is the x values. Take a look at the not a function. Remember, x is what we want to look at. And already I notice that 1 repeats, so that's why that is not a function. So now let's take a look at tables. Tables really are just a bunch of points organized into a table. That's it. So let's look at the first table. Again, we want to look at the x values. 1, 3, 5, that's why it's a function. No repeats. Same thing here. 1, 3, 5, no repeats. Now let's look at the non-examples. So let's look at the x values. Already I see 1 repeats. Same thing here. 1, 3, 1. Under the x, 1 repeats. That's why it is not a function. Let's take a look at our graphs. So when we talk about graphs, we want to use what's called the vertical line test. And just to remind you, a vertical line, of course, looks like this, straight up and down. So here's the deal. We said x cannot repeat. Well, if I can put a vertical line on a graph and that graph only touches that vertical line at one place, that means the x doesn't repeat. So let me show you what I mean. So I'm going to take vertical lines, and do you see how only 1 point at a time touches that vertical line? That's why this is a function. It passes the vertical line test. Let's look at this one. No matter how many vertical lines I draw, this line only touches each of those vertical lines at exactly 1 point. That's why it's a function. Same thing down here. Now, it looks like it might touch it more than one place, but it doesn't. See that? So this is a function because it passes the vertical line test. So let's look at some that fail the vertical line test. Right here. Look at that. This touches that vertical line in 2 places, so that is not a function. It fails the vertical line test. This one fails it all kinds of times. It touches each one of these vertical lines gets touched 2 times, so it fails the vertical line test. That graph is not a function. And then you've got your closed circle or closed shapes. Those always fail because they touch vertical lines at more than one place. Same thing with sideways shapes like that. So the reason those graphs are not functions is they fail the vertical line test. And finally, let's take a look at equations. Equations typically, sorry about that. Sorry about the bell. Typically, we look at the x's, but in this case, this is the only time you look at the y. And here's what you need to know about equations. Y cannot have an exponent, and x cannot equal a number. So I'm going to look at the non-examples or the not functions first. This right here is why that equation is not a function, because y has an exponent. X can have an exponent, y just cannot have an exponent. And then this one, x equals 3, well, when I graph that, that is a vertical line. So it fails the vertical line test 1,000,000 times over. So those are the only two examples of not functions when it comes to equations. All of these others, look at this. Y equals 3x plus 2. 4x plus y equals 9. Y equals x squared plus x plus 2. Even fractions are okay because, watch this. Let's look at the y's in these equations. Does that y have an exponent? No, that's why it's a function. Does this y have an exponent? Nope, that's why it's a function. This one, no exponent, function. This y has no exponent, so it's a function. So please use your graph here or your chart to help you identify functions versus not functions.